Hi guys, Dr. Justin Sarvi here, going through semester test 1. This is page 2. Right, so question 4 asks you to write the following in sigma notation. This is particularly simple. There are a couple of ways to do this. You need an index. Let's use n, and n is going to start at 2, 2, 3, 4, 5, and stop at 5. So n is running from 2, all the integers in between, 3, 4, stopping at 5, and what are we summing? Well, we're summing y to the power of n. Okay, that would have got you your mark. You could have also got a mark if you had n is equal to 1. You want to start at 1. Now you're complicating your life a little bit, because now y is to the power of, it can't be to the, doesn't start at y to the power of 1, it starts at y 1 plus 1. So you've got to go n plus 1, and of course you've got to be a little bit careful where you stop now, because you can't stop at 5 up here, because then you're going to stop at 5 plus 1 is y to the power of 6. So then you've just got to make sure that you stop at 4. Either of those would have got marks. There were a couple of other solutions. There were a whole lot of solutions that got only half a mark, unfortunately. Okay, question B. Now I chose n in the first in A for a reason, and it's because I wanted to emphasize that in A it's okay to use n because there's no n over here, but in this question you can't use n as the index. I can't start at n is equal to something, because then I'm going to run from n is equal to 1 up to n, and n can't run from 1 to n. N is n. You have to use a different index to the one that is in the sum. So let's use k. I is also a good one. In fact, anything other than n is good. You could have used x. So we're going to run from k is equal to 1, because we've got things here that are going 1, 2, 3, 4, all the way up to n. We'll sort out the denominator in a bit. And now we don't know what's the work, what is the term that we're adding each time. Well, it's k. As k is 1, as 2 is 3. It's k divided by something. Well, here it's 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, 2 to the power of n. It's 2 to the power of our index term, and our index term is k, 2 to the power of k. There's a good way to check whether your answer is correct. You can always go and work out what this is if you were to expand it. So you start at k is equal to 1, you substitute 1 into there, 2 to the power of 1, plus you increment k by 1, you get 2. You put 2 wherever there's a k in the term, 2 to the power of 2, 2 over 2 to the power of 2, plus increment k to get 3. You get 3 wherever k is, over 2 to the power of 3, plus all the way up to, you stop when you get to k is equal to n. So wherever you see k, you put an n over 2 to the power of n. And if you multiply these out, you'll see it's exactly what we have over here. But of course, that is just a check. Not a difficult question. A lot of you battled with it. A lot of you put n's over here. What some of you did was to put a different counting variable over here. So you put I is equal to 1 to n, but then you wrote n over 2 to the n. Okay, that n never changes. That's just when you stop. It's the term here that changes. So you needed to do that to get full marks.